Hey, this is chapter 16. It's about sheet metal processes and some other equipment about these processes. You see, we'll be covering most of the subsections, but there are some details, and you're not responsible from these subsections. And with these processes, what we can manufacture the bodies of the cars, home appliances, cookware, tanks, any kind of office furnitures, some trailers, so some pipes can be manufactured with the help of sheet metal processes. So we can say that these parts are all around us, and you can see many parts in your home which are made of using sheet metal processes. And the main advantage of these sheet metal processes is that the resulting pieces usually have lightweight, and you can easily give various shapes, versatile shapes to these sheet metals to obtain various products. You can see, for instance, some examples here. Some cutting is performed, bending performed, forming, deep drawing, so spinning. These are the processes we are going to discuss in this chapter. Another thing is that we mostly perform these processes at room temperature. Since the metal is a sheet one, so the thickness is not high. If you increase the temperature, then probably it's going to be deformed and you cannot have high quality resulting workpieces. So that's why we perform these sheet metal processes mostly at room temperature. Now I will start discussing the first one of the important sheet metal operations, manufacturing operations. This is shearing, and all actually sheet metal operations starts with a blank. The blank is actually the desired part, the part we want to work on, and you can obtain this blank part with the help of shearing process. So it's a kind of a cutting process. We obtain this blank part by shearing operation on a large sheet metal. And how we perform it, we make use of a punch and a die, and once we apply shear forces, shear stresses are actually the main mechanism responsible for this cutting operation or manufacturing operation. I can show you an example picture here. This is the die, as you see. We put our sheet metal in between the die and the punch, and then once we apply this force, some cracks actually starts at this points at the upper side and at the lower side, and then once these cracks propagate and meet at this center point, then we can say that this shearing process is completed. And you can see that some parts have grainy surface or high surface roughness, you can see, and some parts have uh, shiny surface, and these are called as burnished zone. You can see burnished depth, rollover depth. This is about actually the relation between the punch and the die. And after that, after rollover depth, we have a burnished zone. This is shiner, but the rest is actually quite rough, and this is called as fracture depth. And at the tip, as you see, we have burrs, and you know that there are deburring operations. You can remove these burrs. And here, another important thing is actually the clearance between the diameter of our punch and the diameter of die opening. This is called as C, and it's highly important, this clearance. We will discuss it. You should find the appropriate amount of clearance for your specified material and operation. And this is a simple shearing operation. These are things I said, discussed. We have cracks, and once these cracks actually meet, then the process will be completed. In this chapter, as you see, we will discuss many operations. These are all sheet metal operations. And make sure that you review this part after the chapter is over. And in the shearing operations, what are the important issues? The shape of the punch and the die, obviously, since they decide on the resulting part. The diameter of the resulting part is determined by the punch and the die. And the clearance, as I said, is highly important. The speed of punching, it determines the quality on your side surfaces. And again, lubrication or increases the life of your die and the life of your punch. And we can simply increase actually the edge quality, side surface quality by increasing the punch speed. With the help of it, you have more burnish zones and less rough surfaces so that the overall quality of the side surfaces will be improved. And we can improve this actually ratio, the ratio of burnished area and the rough area if you increase the ductility of material. So since this ductility is improved, then that means it will be easier to remove when you have shinier surfaces, or this ratio may be decreased, increasing the sheet thickness. Since once you perform the shearing operation on a thicker workpiece, then probably you will have more cracks and the side surfaces will be rougher than the thinner sheets actually. These are the issues I mentioned. Another issue is that we don't have perpendicular side surfaces. If the thickness is low, we may be close to the perpendicularity, but if the thickness of the workpiece is high, then we will have such an angle. This is called as fracture angle. Another issue about the burrs, it actually increases once you increase the clearance and the ductility of the sheet metal. Since once ductility is improved, then that means you'll have a soft metal, you cannot have easily cracks generated. So in such cases, the height of the burr, these burrs will be increased. You can see some numerical analysis. You can see on all of them that the clearance is highly important. If you have too much clearance, you see you have rougher surfaces, since it will be difficult for these cracks to meet. But if you have appropriate amount of clearance, that is actually much better. But if you look at the first one, I think in this one we have less clearance, so you have it actually weird shapes on your resulting workpiece. Now let's have a look at some types of shearing operations. The main types are punching and blanking. In some textbooks, actually, instead of punching, they may be using piercing term, but they are referring to the same idea. Let's have a look at this image here. If you are going to use that part, actually, that part, the blue part, if it's going to be used, then this is called as punching. But in this case, if the removed part is going to be used, then it's called blanking. As you see, we are using the same punch and same die, but if the remaining region is going to be used, then it's called punching. But if the removed part is going to be used, then the process is simply called as blanking. And you see we have some further shearing operations here. If you have some successive, let's say, holes, this is called as perforating. If you remove material from the side surfaces, it's called as notching. And if you divide your sheet metal into two parts, it's called as parting. And if you have a kind of a tap without removing it from the main metal, it's called lancing, so that you may do later bending operation. Or if you use a kind of a roller from the bottom and top, it's called as slitting. Let me show you this tool. This is a tools which can be used for slitting operation. If you apply too much force, then it may be cutting operation, but you may decrease the thickness so that later one can easily break this sheet metal. It's very similar to actually can openers you are using in our daily life. It's highly, let's say, nice process and can be used on various type of applications. These are some details. Make sure that you go through the details of these processes. Now I will be focusing about on actually fine blanking. We discussed the blanking, but what is fine blanking? If we apply an extra pressure on this sheet metal, you see we have our sheet metal in the earlier version. We didn't have an extra, let's say, holder on this side. You see we only have a punch, but we don't have anything here which is squeezing the sheet metal. But if you have it, then it's called as fine blanking. and with the help of the quality of the side surfaces improves. You see, this is the case without fine blanking. It's the side surface, and you see we have more burnish zone. This is the schematic of it. We are using an extra pad. These are called as pressure pad. And once you have them, then you will have no movement. Actually, the sheet metal cannot move. And with the help of it, you can decrease the clearance in between the punch and the die. And with the help of it, the quality of the side surfaces will be improved. Now we will be talking about the dies. So we said that clearance is highly important, and this clearance you cannot decide on yourself. You should check the type of material you are going to manufacture, its temper properties, its thickness is highly important again. And the other issues are like, for instance, the thickness is the most dominant term actually in terms of clearance. By checking it, you can decide on the clearance roughly. Then later, you may do some maybe experiments and do some numerical analysis to decide on the best clearance value. And you see here on this picture that we have a kind of a shaving process, shaving and sheared edge. So after this shearing operation, we may have a rough surface. And if you are not happy with that, what do? You use a kind of a shaving tool and remove that part. And instead of using a secondary process, what we do sometimes, we use an embedded shaving edge into our shearing tool punch. As you see, this part is responsible for shearing, and the upper part is for shaving operation. So with a single operation, we can have high quality surfaces. Now I will be talking about some types of dies. There are three types: compound dies, progressive, and transfer dies. Now let's start from the compound dies. The thing is that in compound die, with a single operation, we perform at least two shearing operations, and this is performed at a single station. We don't actually move our sheet metal from one station to other, but instead we keep it on the same place and perform at least two operations at a time. And this is called as compound die. And the thing is that it's quite complicated. It's an example of a compound die, as you see. For low number of productions, it's not preferred, but if it's a kind of a mass production process, then you may go with that. Otherwise, it's quite expensive and not suggested for low numbers of production. So what is on here? Let me try to annotate this issue here. So this is our sheet metal, as you see, and we have two punches actually. This is the first punch, and now once this is actually close to each other, once you move this upper part onto the lower part, like this one, then the first thing we will do is actually remove this part. This part will be removed. The larger piece will be obtained with the help of the punch we have here. And then later, since we have a kind of a spring here, it will be activated later on. And with the help of the secondary punch, it will go into this blank material and have an actually small hole at the center. So I can say that the resulting shape will be like this one. It's a kind of a bushing, and as you see, obtained the single movement of our larger, let's say, head. Now I will show you other types of, this was the first example, compound die. Now I will show you progressive dies. This is actually illustrated in C and D. The difference is that this time we don't have upper and lower punches, but again we have a single head, and on this ram or head we have several punches. It may be at least two, or it depends on the complexity of your resulting part. You may have 3, 4, 5, it's up to you. But the thing is that again, we are using a single station but have several punches connected to the larger ram. So what is on here? This is called as progressive, since what we do, we feed our, let me annotate again, we are feeding our strip material in this direction. And at the first, what we do, with the help of this small punch, piercing punch, we open this little hole here. This is the first operation performed. And then we feed our strip to the left. And then what is done, with the help of this larger punch, we are opening a larger hole. And this part, this washer bushing, is removed from our strip. And as you see, in order to increase the accuracy of this punching operation, we have a pilot, and this pilot actually goes into this hole, and then the larger punch here actually removes the resulting washer from our strip. So once we feed it continuously, we will obtain our washers in a kind of a mass production manner. And if you look at the image on this right-hand side, you'll see that our washers are a bit more complicated, so we cannot perform them in just by using 2 punches. Instead, we have many punches, and after some operations, we can obtain our complicated shapes. And the last one is transfer dies. As the name implies, this time we are transferring our sheet metal or strip to different stations, and at each station, we are performing different operations. And furthermore, we can have some cutting operations on sheet metals there. They can also be considered as shearing operations. We can do laser beam cutting. We have already discussed that. Water jet cutting can be performed again on the sheet metals. We can use band saws, friction sawing, and flame cutting. This is a kind of a thermal process, and it's mostly performed on thick plates. So once you increase temperature, and that part will be actually melted, and you will be dividing these thicker, let's say, sheet metals into smaller parts.